Canvas site, in the assignments area, you will find the assignment for the box calculator. And in this project, we are doing some mathematical calculations and displaying the results to a specific number of decimals. There's a PDF here for the instructions. There's also an exe that you can download that you can run the file and play around with it and see how it works. And finally, there's a graphic here that you're going to use in your project, and it's 186 by 192 pixels, so you can put it in a label, you can put it in a picture box, but to get it you simply right click and choose Save Picture As. So the instructions are here. There's also some sample test data and instructions on submitting your project, and this is worth 2 points. The first 2 CSLOs of the 162 AD course. Let's take a look at the PDF. It's the same instructions you'll see in the Canvas site, it's just a little bit easier to read here in the PDF. So what you're going to do is you're going to create an application that shows the box, and the user is going to enter the height of the cube, the width, which is here, and the length of the cube. Click the Calculate button, and it should show the volume. The volume, of course, is width times height times length. The surface area, and I'll explain that in a minute, that's basically how much cardboard would it take to create this box, or the surface area of this cube of all 6 sides added together. And then the circumference. If we were to add a string or rope around this cube in each of the 3 directions, how much length would that string or rope need to be? So you'll see the orange goes around the top and the bottom and 2 of the sides. The blue rope goes around all 4 sides, and the purple goes around the top and the bottom and the other 2 sides. Let's take a look at this running. Here's the cube calculator. So I have default of height being 8, the width being 5, and the length being 10. If we click calculate, then that volume, 8 times 5 times 10, is 400. The surface area, which is going to be, in this case, on this side, would be the length times the height, and the other side as well. This one would be the width times the height, as would be the back side. And the top and bottom would be the width times the length. And adding those 6 together, we'd get 340. The orange circumference rope going around here, in this case, is going to be 26 units. The blue one would be 30, and the magenta or purple would be 36. And I give you in the instructions the sample data results so you can test your application. And I would test all 4 of these, especially the decimal places. Make sure that you've used the correct data type. So I'm going to say the height is 26.7, 10.33, and of course I'm doing the very last sampling of data, and 15.25. And our calculate would be 4,201.39. Again, we're rounding off to 2 decimals. Our surface area is 1,679.5, and the circumference is 74 for the orange, 51.16 for the blue, and 83.84 for the magenta. So our application is working just fine. Let's take a look at that surface area and how you can better define that. So here then is the surface area of our box, or our cube. If we were laying this out maybe on a piece of cardboard, how many square units would it take of that surface area? And so again, we have 6 sides, of course, and so 2 of those sides, the bottom and the top, are the length times the width. Side A and side B are the length times the height, and side B and D are the width times the height. Notice there are 2 for each one, so you could take the length times the width, multiply that by 2, add the length times the height, multiply that by 2, and add the width times height multiplied by 2, and that would give you the surface area. For the strings going across, figure let's look at the blue circumference. Here we're going the width, and we're adding the length. On the back side, we're adding the width, and we're adding the length. That would be the blue one. You can figure out the magenta and the orange ones on your own. So that's the assignment. Good luck.